Now, we'd like to welcome the 36th project of a National Young Fuerscher contest. Coming from St. George's International School, we have Sebastian ROE, who will present his project called Does the Improper Storage of Aspirin Compromise its Potency? Let's find out shortly.
Good afternoon. My name is Sebastian ROE, and like I said, well, they said, for my project, I chose to do, does the improper storage of aspirin compromise its potency? So I had to actually find a way to, I had to find a method. So I built this. It's called a colorimeter. But why does it work at what it does? Well, it's due to something called the Beer Lambert Law. And what that states is that the light absorbance of a solution is directly proportional to the concentration of the attenuating species. What this means is that a specific kind of molecule or species is reducing or attenuating the amount of light that can pass through it. What this means is that more light passing through equals a lower concentration of whatever you're testing for. And in my case specifically, more light intensity equals less degradation. And then I've got this fancy animation. So basically, at a low concentration, a lot of light passes through, but at a high one, less light passes through. It can be written mathematically as the overall light is equivalent to passed light plus absorbed light. This is my colorimeter. So onto the actual experiment then. Aspirin breaks down with water to create 2-hydroxybenzoic acid. It takes a stupidly long time. So the same product can be recreated more hastily by using mixing aspirin and sodium hydroxide. Adding iron 3 chloride will turn this colorless, undetectable solution purple, and obviously this new purple solution can be detected by my colorimeter, and using new aspirin, I can make a calibration graph so that my experiment actually works. So here they are, and obviously that's how it works. I stored 2 types of aspirin named Fast Tabs, which is a coated tablet that's designed for quick release, and Aspirin 100, which is a Dutch brand that is uncoated. I've stored them in 4 different locations for around 90 days. These were the warm, moist bathroom, the variable car, the hot, dry radiator, and outside, which has just loads of factors, so it's quite interesting. Each location had 3 tablets of each variety to prevent anomalies. So here it is. The remains of the tablets were dissolved in water, giving this colorless, not this colorless solution, but a colorless solution. So again, iron 3 chloride was added so that it turned purple. And so this again can be tested by the colorimeter, and light intensity was tested, and it was measured in the colorimeter. So using the fancy calibration graph that I showed you earlier, we could test the aspirin. We could test how much degradation it had. So what are my results then? Well, for aspirin 100, decent results. The bathroom was definitely the best off, which shocked me a little because it's very moist in the bathroom. So I expected there to be a lot of degradation, but it was actually between 5 and 10%, which is quite low comparatively. Outside and the car, they didn't fare too well. However, they were a lot better than the other tablet that I picked called Fast Tabs. Both outside and the bathroom were completely dissolved, which is absolutely terrible for an experiment. In the radiator, there was high levels of degradation, over 35% and up to 60.7. And in the car, there was only a trace amount remaining, so you can't really test it. So how would I evaluate this? Well, there were a few things. Although the colorimeter behaved according to the Beer Lambert Law, and the graph was produced with really high accuracy, with 97% and 98% accuracy, with the R-squared value, light interference was a problem because, as you can see, there's nothing preventing light from outside getting in, so the lighting in the room would change everything, and even the angle. The cuvette size was a massive problem because it could shift, and obviously the light could refract, giving a different result than what we want. Checking on tablets was a problem because, as we saw, 2 of the tablets for fast tabs were completely dissolved. And using pure aspirin was an interesting one, because aspirin that I used to compare has bulking agent and other compounds. The problem with this is it's very difficult to get pure aspirin for multiple reasons, even in an actual lab. Oh, there it points out the size. I also would have tested with different drugs, such as ibuprofen and paracetamol. I also got a suggestion that I should use iodine pills, as they're said to have a shelf life of 10 years, which is interesting because in the case of a nuclear fallout, we need to know that we can actually use it and not die. So, how did I fix these problems then? Well, I built this. It looks a lot more professional than the prior design, and everything is hooked up. It's a lot more user-friendly. It just works better. As you can see, there's a housing right here. In fact, there's a housing right here, which there's a housing right there, and obviously right there, which meant that the cuvette couldn't move, as you can just put it on and shift it into position, which is fantastic for me. And that housing also has the additional advantage that light can't get in from outside, as obviously it's a closed-top housing. So that was really useful. So, does the improper storage of aspirin compromise its potency? Yes, but the reason we need to know this is because 2-hydroxybenzoic acid, common name salicylic acid, is actually its own pharmaceutical in itself. It's actually used to remove the top layer of the skin, often used as an acne treatment. However, in high doses, such as the ones you could get from heavily degraded aspirin, then it can actually cause intoxication, causing dangerous decisions and a delirious mind.
Welcome, Sebastian. After your presentation, we're going to ask you a couple of more questions to learn more about you and your project as well. To start off, maybe just how did you get the idea for your project?
Well, there were a couple things. I'm very passionate about science, and I'm very much planning to pursue a career in the field. So when I was researching available pharmaceuticals to use for my experiment, I thought that maybe aspirin would be a good idea because it's very commonly used, and it's also incredibly easy to buy over the counter, unlike some other pharmaceuticals. And then, obviously, after that, I wondered if it degraded, because obviously, if your pills are degraded, they're not going to work as well, are they?
And so are you interested specifically in, I'm guessing, chemistry, biology maybe, or more generally?
Generally medicine and generally just science, but I'm planning to become a doctor. I am interested in pharmaceutics. It's not quite my favorite part of science, but it's still a very, very fun part. It's got a lot of interesting things, like, for example, the whole reason I used iron 3 chloride was to test for the phenol group, which salicylic acid is part of.
You sound passionate in any case.
You can see that clearly. Maybe a question which might be interesting for our audience. So you answered your research question regarding does the improper storage of aspirin has an effect on its potency with yes. So in simple words, how should we best store aspirin or any kind of other pharmaceuticals, medicine at home?
Going off my discussion with the jury, I would very much advise to use the original blister packs because they are quite well engineered to stop air passage into the pills, and obviously moisture as well. They're quite moisture and airtight.
Brilliant. Good then. was there any surprising factors you discovered during your research? Or obstacles, let's say, which you've seen during your research?
I think that there are a few things. I think that sometimes I use the circuit wrong. Like 1 or 2 times at the start, a battery just died on us, which was incredibly upsetting because we had to wait a week for a new one at least, which was quite annoying because it meant we couldn't test as well.
Yeah. Looking ahead on future career paths, what is up for you looking ahead in the future?
I'm planning to become probably a radiologist, but I'm interested in pretty much all medicine. The type of doctor that I'd be least likely to become is probably a surgeon, just because my hands shake a little bit, which obviously isn't a problem with this experiment, which is very good.
Brilliant.
Do you have any advice or tips to other people who would like to participate in the Young Fuerscher contest?
Don't get too worried. You're not going to do badly. If you do get too worried, just breathe and try not to hurry too much, or you'll start stuttering and then get worried. So try not to do that, but just relax.
During the presentation, I'm guessing? All right.
Very well.
Thank you very much for your time, your presentation. Congratulations for the work so far.
Thank you.
And I already wish you good luck for tomorrow then.